Welcome to Solutions and Equilibrium. So, solutions is a topic that we talk about a lot in chemistry when you combine multiple things together. Usually, a solution involves some water and you pouring something into the water and mixing it up and forming what's called a homogeneous mixture. Remember when we talked about mixtures, you have homogeneous mixtures and heterogeneous mixtures. Okay, a solution is a type of homogeneous mixture where, again, usually it's water and then you put something in it and you stir it up. Okay, when you form a solution, there is no chemical reaction that's taking place. Usually it's just, again, some sugar or some type of chemical that is dissolving or mixing around completely in that water or whatever you're mixing it up in. Now, when you form a solution, let's kind of draw a little picture here. When you form a solution, you've got your water here, and then you take something, and again, like I said, it could be even some Kool-Aid or something like that. You dump some Kool-Aid into here. Okay, there's three different parts to the solution. Okay, there's this part right here, the water. The water is what's called the solvent. Okay, a lot of times you might hear water referred to as the universal solvent, because if something's going to dissolve, most of the time it will dissolve in water. And then the stuff that you're putting into the water or the solvent is called the solute. Okay, so the Kool-Aid or the sugar or the salt, that would be the solute. Okay, once you have the salt or the sugar in here, now you've got the solvent and the solute mixed together. Now both of those together make up the solution. So the solution is the combination of the solvent, the water normally, and the solute, the salt, the sugar, whatever it happens to be. Okay, here's just a few examples of different types of solutions, but really, like I said, the main one that we talked about is taking a solid like sugar or salt and putting it into water. But it doesn't necessarily have to be. Even the air that we breathe is an example of a solution. Okay, because it's a mixture of nitrogen and oxygen and carbon dioxide and water and all these different gases. Now, when you start to add this, let's say we're going to make some Kool-Aid. You start to add some Kool-Aid, and then you add some more, and you like your Kool-Aid really, really strong. So you keep adding more and adding more and adding more. You're going to get to a point where basically there's no more room for that Kool-Aid to dissolve. Okay, and it takes a lot of Kool-Aid, don't get me wrong. Okay, but eventually you're going to get to a point where there's basically no more space in that water for that Kool-Aid to dissolve. And so what happens is you keep pouring more Kool-Aid in and it won't dissolve. It'll just kind of sink to the bottom. And you stir it up and stir it up and stir it up, and then it still sinks to the bottom. Okay, that means that you've now reached what's called the saturation point. Okay, when you have what's called a saturated solution, it means that you've got the maximum amount of the Kool-Aid in that water. You can't dissolve any more of that Kool-Aid in that solution. Okay, normally when you make Kool-Aid, you have what's called an unsaturated solution, which means, yeah, I put in some Kool-Aid, but I don't want it to be too sweet or taste too strong. And so I could still put some more in, but it tastes right to me now. Okay, that's what we call an unsaturated solution. It means you could still put some more in there, you're just not going to. Now, if you take that Kool-Aid and this is how syrup is made. If you take that Kool-Aid and you put it on the stove and you heat it up, then you can pour some more Kool-Aid in and you can mix it up some more, and it will still dissolve. Okay, and if you do that, then you're going to let it cool back down. You're going to create what's called a supersaturated solution. So that again, the common way that you can create a supersaturated solution is by heating that water up, and then that more of that solution or more of the solute will dissolve in that solvent. Okay, one of the ways that we measure, like when we were talking about Kool-Aid, I said, hey, to make that saturated solution, you just kind of keep pouring more and more Kool-Aid in there. One of the ways that we can measure how concentrated it is, like a lot of times you might taste the Kool-Aid and you go, it's not strong enough, or it's not sweet enough, or you might go, ooh, it's too sweet. Really what you're talking about by saying it's too strong or too sweet or maybe not sweet enough is you're actually talking about what's called the concentration of that solution. So one of the ways that we measure how concentrated it is, first of all, is we taste it. Okay, now in chemistry we don't actually taste it, but when you're making Kool-Aid at home or some type of drink at home, you might taste it and go, that hot chocolate isn't chocolatey enough. I want more chocolate in it. Okay, that you're saying what the concentration is too low. Or you might drink that hot chocolate and go, oh, that's way too chocolatey. Well, then that concentration is too high. Okay, so one of the ways that we measure the concentration is we measure the masses of what we're putting in. We measure the mass of the solute, and then we measure the mass of the whole solution, and we just compare those two. Okay, and what that's called, surprisingly, is called the percent by mass. Okay, and we might have talked about that a little bit when we talked about moles. Okay, but that is one of the ways that you can calculate how concentrated the solution is I'm going to take my Kool-Aid and I'm going to measure it out. Now, normally it'll say, measure 1 cup of Kool-Aid for every 1 gallon of water or something like that. Okay, in this case, we take the mass of the solute, which again, remember, I'm going to just keep using Kool-Aid as an example. Okay, the mass of the solute would be how much Kool-Aid am I going to put in there? Okay, and then I'm going to put the total mass of the solution. Be careful there because that's not just the water. The mass of the solution is the water. Remember the solution? What's the solution? It's everything. It's the water and the Kool-Aid put together. Okay? So look at this example here. In example 1, it says, a solution is made by dissolving 13.5 grams of glucose, which is just another word for sugar, in 100 grams of water. What is the mass percent of glucose in this solution? So notice I put the mass of glucose on the top, and notice on the bottom it's not just the mass of the water, it's the mass of the glucose and the water. Because again, water is the solvent and glucose is the solute. And the solution is both of those together. And that's what has to go on the bottom. The bottom has to be the mass of the entire solution. Okay, so notice I take 13.5, I add these two numbers together on the bottom, I get 113.5, and then I take 13.5, I divide it by 113.5. To get a percent, you've got to multiply by 100, and we've got about 11.9% is of that solution is glucose. Okay, let me show you one more example, and then we'll be done. So example 2 says 6.44 grams of magnesium chloride, MgCl2, is dissolved in 80.1 grams of solution. Okay, now be real careful there, and I bolded that word on purpose. And then it says calculate the percent by mass of the solution. Notice that in this case, because I said solution, that means I'm including the MgCl2. In the first example, again, look at how I worded it. I said water. Okay, water is not the solution. Water is the solvent. So when I say 80.1 grams of solution, that's everything. That's the whole bottom part of my fraction. So it's not necessary to add the 6.44 grams to the 80.1. And again, it comes back to you reading the problem carefully and making sure, wait a minute, do I have to include that or do I not? So all that I need to do is I need to take 6.44 grams and I'm going to divide by the 80.1 grams of the solution, and now I'm going to multiply by 100. So basically all that I'm doing when I say solution is I'm trying to make it easier for you. It means that I'm already adding the 6.44 including it with the mass of the solvent. If I wanted to know what the mass of the solvent is, certainly I could take 80.1 and I would just subtract 6.44. And that tells me I have 73.66 grams of the solvent. But do I care about that? No. Because all I care about is I need the mass of the solution on the bottom. Oh, he gave me the mass of the solution. I'm just going to put that on the bottom. So just be really careful when you're doing problems like these. Make sure that is it the mass of the solution on the bottom, or do I need to add the mass of the solvent to it? And again, I'll always make it very clear in the problem how you actually are going to do that. So now I just need to take 6.44 and divide by 80.1, and then I'm going to multiply by 100 to get a percent. And if I do it right, I get 8.9%. 0.04%. And that means that in this solution, that again, it doesn't say it, but it's probably just water, about 8% of that mass is the magnesium chloride, which means the other almost 92% of the mass is certainly going to be just the water.